Hey everybody, thanks for tuning in. We're going to just wait here a few minutes while the webinar is getting started. We still have a lot of you jumping in, so this will give us a few more minutes to let everybody get on there. Now there's 4 of us presenting today and we're scattered all over the country, so hopefully all our computer connections work as planned. If for some reason the audio doesn't sound very good or if there's something wrong, there's a chat bar on the right-hand side of your screen. So let us know if something isn't quite working right. Also on that same chat bar, please ask questions at any time and we will address those questions at the end of the presentation. We have a lot of you tuning in, so we'll do our best to get to all of those questions. If for some reason we don't get to yours, we will follow up with you guys via email. All right, we're getting the thumbs up that all technical things are working right, so we'll get started. Thank you for tuning in to another Straight Talk webinar. My name is Michael Kuzatz, and I'm an Avionics Regional Sales Manager here at Duncan Aviation. Now today we're going to be talking about Datacom because it's been a popular request out there, and there's some confusion between fans and ACARS, CPDLC, departure clearances, pre-departure clearances, and there's also discussion of mandates, in Europe and maybe United States. So there's a lot of things to clear up. Helping us cover all the material today, we have our friends at Universal Avionics who've been in the Datacom business for quite a long time. So on the call today, we've got John Spellmeyer, who's also an avionics sales rep here at Duncan Aviation. John's been in the industry for quite a while. He's started flying B-52s and B-1s in the Air Force. So John, as always, glad to have you on board.
Good morning, Michael, and thanks everybody for joining us today.
We also have Lynn Root. Lynn is the technical product manager at Universal Avionics. She's been with the company for 22 years, and she started in systems engineering with data link products. So Lynn, you've been working on this system for quite a while, haven't you?
Yeah, I've worked on the Unilink system since it was just an idea on paper, and I've been involved with data link technology for just shy of 30 years.
Jeez, well, thank you so much for being with us today. Also, we have Amanda Grizzard. She is the customer training manager at Universal Avionics. She's been with the company for 15 years, and she started off in avionics in the Air Force as a lowly line tech on the EC-130. Amanda, thanks for being with us today.
Thanks, Michael.
So we're going to jump right into it. And again, remember, if you've got any questions right there on the chat bar, you can ask those. So the idea of texting in our society is obviously extremely common, but the texting from cell phone to cell phone has only been around since like the mid-90s. But texting to aircraft has been around for a long time. But exactly like when was data link first used and how were we first introduced to data communications in aviation?
Well, I can start out here. So Aircraft Communication Addressing and Reporting System, known as ACARS, was actually introduced in the late 1970s. And again, it was to provide a text messaging-like service between the flight crews and airline support personnel on the ground. So today, there are actually 3 different services that use this ACARS network. There's Aeronautical Operational Control, or what's known as AOC. There's also Air Traffic Services, known as ATS, and then the Air Traffic Control Services, which is ATC services. But it all started with the AOC service offering. So right from the start, there were some clear benefits to using data link over voice. The information exchange was much quicker. Voice radios on the aircraft were not always tuned to the airline frequency, but ACARS is an always-on communication system between the flight crews and the ground support personnel. Works anywhere in the world that the ACARS connection can be established. So it's very similar to the text messaging service you have on your phone, except it's between the support personnel on the ground and the flight crews on the flight deck. The messages sent and received on the aircraft are maintained in a log, so they can be revisited at any time, and this can be especially helpful if the information that received is complex, so you can have it right in front of you to review it and process it. So as I said, the messages are clearly displayed on your flight deck display. So there's no more confusion over what was said if the radio signal got garbled or if an accent was unfamiliar. There's, significantly reduces the need to request say again. So all of these benefits improve efficiency and reduce flight crew workload. You have to no longer need to frantically write down messages using a notepad strapped to your knee. So the quick digital exchange of information, which is eliminating paper and minimizing voice transmissions and the resulting manual data entry, dramatically improved operational efficiency. But let's talk about just a few of the specific AOC services. So AOC was the very first ACARS messaging service, and it simply just allows the flight crew to communicate with the ground personnel. And my first exposure to ACARS and AOC was in the mid-'80s at my first job out of college, where I worked for an avionics manufacturer developing FMS software. I was actually programming the software that processed the AOC flight plan and wind data that was sent by the airline so it could be automatically loaded into the inactive flight plan for the flight crew to review. So there was no more manually entering every element of the filed flight plan at the start of your flight. ACARS also allows the crews to request text weather like actual and forecast terminal information, SIGMETs, PIREPs, or wind information for various points along your route or for other points if you're thinking about diverting or cutting off some of your flight and doing a direct to. The crews can type in free text messages and perform status reportings, such as sending updates or estimated time of arrival, or if you're diverting, you can receive fuel options if you're looking to do a quick turn after you land. What else? So in addition to the route data, similar to the FMS, Unilink can also connect to central maintenance systems if they're ACARS compatible, and you can actually get reports on engine exceedances or engine trends. But this AOC service offering that's standard with Unilink today, it just all started with a desire to replace voice communications with data.
Super. Hey, Amanda, aeronautical operational control data link messages, they're still used quite a bit today. What other AOC messages does the Universal Unilink support?
That's right. So they still are used today by operators across the industry. And probably one of the most sought after applications or services of aeronautical operation control is URI reporting, or out, off, on, in. And this simply means that when one of these events occurs, the equipment automatically sends a message to the operator's control center or a recipient on the ground. Airlines loved this because it automated the pay clock. So when an out report was generated by closing the door and releasing the brake, the operator's control center would automatically receive a message and they would start the crew's pay clock. Off report was weight off wheels, on report was weight on wheels, and the in report was brake set, door opened, message goes to operator's control center, and the crew's pay clock stops. This can also be applied in business aviation. There's a pharmaceutical operator that flies helicopters from one hospital to another hospital, and they use the off and on reporting to help track those helicopters throughout the day. I've benefited from URI reporting as a director of maintenance on an aircraft for a bit. I really enjoyed getting a message to my cell phone letting me know when the boss had landed. That way I knew I needed to head out and greet the aircraft. And then I would get an off report when I knew that the aircraft had taken off and I didn't need to hang around anymore. Big sigh of relief, head back to the office and get some work done. Additionally, automatic position reporting can be used to help track aircraft. And this simply means that when the equipment was installed, it was configured to send position information automatically at predetermined intervals while the aircraft is operating. If by chance they want to send an additional position report, the pilot can just push a button, and we call this manual position reporting. To add to all of these efficiency improvements that we see with the AOC messaging, with the Unilink data link solution, we can customize the AOC database in order to really improve the efficiency of the messaging service.
Hey, Lynn, we can see why the airlines wanted to use this technology and how it benefits the business operators as well. You had mentioned other data link services like air traffic services. Can you explain that service for us?
Yeah, sure. So not all of the information to improve efficiency was available at the airline or at the ground host operation center. Some data, like Digital Automatic Terminal Information System, or DATIS, for your departure or arrival airports, were stored in Tower Data Link Services computer systems. Those are TDLS computer systems. Um, and those services are made available to all ACARS operators. So these are the ATS messages. The TDL system waits for your request, and once it's received, the ground computer generates a response that's then sent back up, and you can again view it on your flight deck display. So during pre-flight, you can get your DATIS or terminal weather information for pilots, which we call TWIP. You can get your DATIS or TWIP for many different airports in the US and actually throughout the world. For the larger airports, you can select whether your DATIS is for your departure or your arrival airport, or for your departure or your arrival at a specific airport. The TDL system also holds an initial text-based, non-FMS loadable departure clearance. So that's kind of important that it's non-FMS loadable, because we'll talk about other departure clearance applications later. But those departure clearances wait until the request comes in, and then when they come up, they're displayed on your flight deck. And then the flight crew has to manually enter that clearance into their FMS if the clearance isn't cleared as filed. So this departure clearance service is also available at multiple airports throughout the world. So it's called PDC because the message definition was a pre-departure clearance, but it's been used for departure clearance services here in the US and elsewhere. Anyway, the departure clearances, well, let me back up. So a few airports can also send pushback and expected taxi clearances. And then while you're en route, you can get a clearance to enter into oceanic airspace over data link, as well as continue to get TWIP or DATIS updates for your alternate or your arrival airport. And that's the summary of air traffic services.
So Amanda, I'm guessing FANS or Future Air Navigation Services, FANS 1A, is that part of air traffic services?
That's right, it is. So Lynn promised that we would talk about AOC, ATS, and ATC messaging. And when we're talking about ATC Datacom, we're generally talking about Future Air Navigation System, or FANS. And right now we're seeing this used in oceanic and remote continental airspace, and it's also being used in domestic airspace like Canada and the US. There's several components. Probably the least discussed and the most important is the Air Traffic Services Facilities Notification, or AFN Log On. And the pilots must request a log on with ATC, and then they wait for ATC to respond and establish a connection. It's only after this connection is established by ATC with the aircraft that the pilot can begin to exchange FANS messages with air traffic control. So before Future Air Navigation Systems, HF radio voice communication was used as the primary means to communicate in oceanic and remote continental airspace. But with FANS, pilots operating in this airspace are directly connected to ATC via a satellite data link connection. This allows a faster exchange of information, eliminating a need to use voice communication. So for those of us who have used HF voice, we see this as a big improvement to how we communicate in remote and oceanic airspace. We know this as performance-based communication and surveillance, or PBCS. PBCS is jointly used with performance-based navigation standards, or PBN, and this is done to ensure the safety is maintained in the given airspace by requiring that all the operators not only meet those navigation performance standards, but that they also meet communication and flight surveillance standards. And PBCS is comprised of two components, and the first of which, controller pilot data link communications, or CPDLC. And this is that text message exchange or the data communication message exchange replacing voice between the pilot and air traffic control. And here on the slide, we can see an example of data communications message exchange between the pilot and air traffic control. And what I'll point out here in this is that when we replace voice communication with data communication, we need to make sure that the pilots are responding just as they would if they were using voice to communicate. We can see the pilot responds to ATC's clearance with a Wilco, and then he reports when he's back en route. Another component of performance-based communication and surveillance is automatic dependent surveillance contract. And as the name implies, this is the surveillance component of PBCS. And this is used to digitally exchange aircraft equipment or aircraft information between the aircraft equipment and ATC. And I'll highlight the point that this doesn't necessarily involve the pilot. When the pilot logs on and ATC establishes that connection to exchange information over the FANS network, ATC also establishes a contract with the aircraft equipment, and the pilot doesn't have to do anything. ATC uses this contract to gather surveillance information, altitude, airspeed, present position, next waypoint, information about the aircraft that helps ATC safely manage the airspace. With the communication improvements and the navigation performance standards and the surveillance improvements, ATC can safely reduce lateral and vertical separation within that airspace, giving more aircraft access to the airspace. And I will note that in places like the North Atlantic, PBCS airspace is usually required that you meet certain, or it is required that you meet these performance specifications. And providing the ADSC information, it allows ATC to predict conflicts up to 2 hours in advance. So we have these periodic reports that gives ATC this information about the aircraft. You can also have waypoint sequencing reports that automatically notifies ATC when the aircraft has passed a certain waypoint, in addition to other ADSC reports such as abnormal rate of descent. A message can be automatically sent to ATC, allowing the pilot to just go ahead and fly when he needs to most and not having to worry about necessarily communicating that to ATC. With that, I'll wrap it up with the benefits. So with FANS, we see more voice communication being replaced with data communication. And this naturally leads to a further reduction in workload and a reduction in miscommunication. We also see an improvement in the speed of communication, and this isn't just because more voice communication is being replaced with data communication. It's also because the FANS network was built to exchange information more quickly than what we saw with ACARS, AOC, and ATS messaging. Then you add in this quick communication with the surveillance component, and you get improved safety of flight. All of this, combined with the navigation element, allows ATC to reduce vertical and lateral separation, giving more aircraft access to preferred routing, all naturally leading to a reduction in CO2 emissions. Because aircraft need to be equipped to get these preferred routing, it is easy to say best equipped, best served.
I think that's we hear. First time I heard best equipped, best served was like during ADSB. Hey, if you upgrade, your traffic control is going to be a little more fond of you. And I can see that's going to be more prevalent with this technology. And we'll get back into that. We've got a poll here. I hope I don't mess this up. So for all you attending the webinar, there's a poll here. We're just kind of curious on which benefit of the FANS system that you guys want to learn more about. And there is a lot there. And FANS is just kind of, as you can tell, is a deep subject. So it talks, we can look at a lot of the workload reduction, obviously the reduction in miscommunication, but also faster communication, improve safety of flight, access to preferred routing, reduce CO2. We've got another one there. If there's something else you want to look at, let us know. I'm going to take a peek at how this looks, and it's kind of a dead heat between reduce miscommunication and faster communication, but actually preferred routing 1. 40% of you actually are looking for the preferred routing. Nobody wanted CO2 emissions to go down, so we're all non-green people. Still moving around. Actually, preferred routing is getting up to about half of you, so it's pretty interesting. So, and I can see why most people want the preferred routing. As the airspace gets busier and busier, we want to be able to move around quicker. I'll end the poll there. Thanks for taking part of that. We're going to jump back into this. So we have talked about the best equipped, best served type of thing, but there's also some, I mean, that's not using a mandate. Now, we've heard about mandates like in Europe. There's been maybe some discussion on mandates in the United States. At times you hear there are. Is there more you can tell us about the mandates and what airspace is going to be affected by those?
Yeah, so there's actually a couple mandates that are already in effect. The first is in the ICAO NAT region, which requires FANS 1A plus equipage between flight level 285 and flight level 410 inclusive. That was a phased mandate where it started out in a narrower altitude band in a narrower region, and it continued to grow. And the last phase of it actually occurred on the 30th of January at this year, which expanded it to the entire region in the altitude range that I already said, 285 to 410. Although there is some temporary relief being granted for this particular mandate right now because of the reduction in traffic over the North Atlantic because of the coronavirus. In order to fly in this airspace now, in addition to being FANS 1A equipped, you also need a letter of authorization. And that letter needs to indicate not only the FANS operation with an approved SATCOM system like an Iridium or Inmarsat system, but also that the system complies with the performance-based communication and surveillance standards. That's the PBS definition that Amanda was talking about earlier. The PBS allows an operator to safely operate on the core tracks when reduced separation is in effect. The specific equipment capabilities of any given aircraft is identified by codes that are part of your filed flight plan. So ATC is going to use these codes to identify the regions that your aircraft can fly. The other mandate already in effect is the European mandate. It requires all non-exempt aircraft flying above flight level 285 to have Aeronautical Telecommunications Network Baseline 1 or ATNB1 services. And that mandate kicked in on the 5th of February of this year. The map shown here is the planned service provided by the ground as of December in 2020. So all the regions shown in green will be able to provide the full set of the planned services. The pale orange states don't plan on providing ATNB1 services. These services use the ATN ground network as opposed to the ACARS network that's used by FANS. And the service actually supports just a subset of the FANS CPDLC message set. But don't worry, the Unilink will automatically adjust what's supported in terms of messages based on which network the equipment is actively connected to at any point in time. This mandate requires that the radio be able to support both multi-frequency and VDL mode 2. VDL mode 2 is the newer radio technology. Its transmission speeds in terms of data link are 10 times faster than the original mode of ACARS network operation. And the UL 801 will manage both the multi-frequencies and the mode of operation, the radio that's embedded within the Unilink UL 801 system. And then to answer your question about whether mandates are coming in domestic U.S. airspace, my understanding is there are no current plans to mandate the CPDLC service in U.S. domestic airspace because the expectation is that the service benefits are going to be great enough that operators will want to voluntarily equip.
I think I'd agree with that, Lynn. So Amanda, this ATNB1 is a new term. Could you explain that a little bit?
I can certainly expand on what Lynn provided us. So she said it's used in European airspace. I'll highlight that ATM-B1 uses a different protocol than ACARS. You might hear the term bilingual used for an aircraft that's equipped to use both FANS and ATN ground networks. These aircraft can use both FANS and ATN when necessary. They can do it simultaneously. And as Lynn kind of touched on, they can transfer between the two relatively easily. And it's not necessarily visible to the operator. It all kind of looks the same. And ACARS, like ACARS, ATN enables the exchange of text messages between the aircraft and the ground, and it was implemented to improve the efficiency and the safety of the airspace. It's a terrestrial-based or ground-based system using the VDL Mode 2 AOA VHF link, but I want to note that they are also doing trials for the use of SATCOM to exchange ATM-B1 data messages, and we should probably expect to see this used in addition to VHF sometime in the near future.
And so that's all in Europe, and it'd be interesting. We probably should have done a poll, but I mean, and that's a great technology over there. But I think we're definitely excited to see this type of technology. It was interesting from the poll that we did have. People are looking for some preferred routing, and I'm going to guess here in the United States, especially if you're operating East Coast or West Coast, I mean, they'd really like to have that. So I've heard about FANS or CPDLC being used in the domestic airspace. And can you tell us a little bit more on how FANS is being used in the U.S. today?
Yeah. So I'm going to start with the tower services. Those are the services on the ground, and that's the CPDLC departure clearance, or DCL. And this service is used to not only deliver your initial clearance, but it can also send your revised clearances via data link as well. So the operators can determine what data link departure service is available at an airport by looking at what JEP users might call the 10.9, but at the airport chart. The magnifying glass in this example is actually highlighting that both the ATS PDC departure that was talked about earlier, it's listed here as PDC, and the CPDLC DCL departure are both available at this airport. So the ability to transmit revised clearances is one of several differences between the DCL, the CPDLC DCL service, and the ATS PDC departure service. So if you recall from our earlier discussions with PDC, you get the clearance, it's displayed on your flight deck display, and if it's not cleared as filed, the flight crew has to manually update the FMS with the clearance. And then if you have a future revision that comes in, that future revision has to be communicated via voice. But with the CPDLC DCL, your initial clearance, if it's not cleared as filed, can actually be loaded into your FMS with the push of a button. So the initial clearance also includes things like your SID and your climb out instructions, your altitude, squawk codes, radio frequency. So this digital delivery with the push to load function is not only faster, but it's also improving safety, because there's no more waiting for busy voice channels to clear. There's no more readback, hearback errors, and no more errors manually entering the flight plan route into your FMS. But a key advantage of the CPDLC is if a revised clearance has to be delivered due to things like rapidly changing weather, then the DCL clearance can be delivered can deliver the revised clearance quickly, and that revision can also be loaded into your FMS with the push of a button.
So Amanda, are there really benefits of CPDLC and DLC to the operator? And this stuff is neat, but is it really available in the United States? And if it is, where is it available?
So there are some great benefits, and we've gotten tons of positive feedback from operators using CPDLC DCL now, and we've got a lot of great feedback. One of the best ways to see the value is to compare CPDLC DCL to a voice ATS PDC. So on the screen, on the left, you can see CPDLC departure clearance, and on the right, you can see a voice departure clearance. The DCL clearance is facilitated in its entirety using the data link, while PDC is via voice, with the clearance being provided and read back. Aside from this difference, we can see that the aircraft equipped for CPDLC DCL took off 6 minutes after its revision was generated and received, while the aircraft using voice took 3 times longer. It took nearly 21 minutes after receiving the revision via voice to take off. So this example really highlights the benefits. But here we can see in this infographic, we can quantify those benefits. In February 2020 alone, we see over 52,000 minutes of radio time eliminated between crews and controllers. This means less miscommunication. We also see over 51,000 minutes of user time saved. This reflects a substantial reduction in the time spent at the gate or during taxi. So we see less time running engines, less time waiting to take off. You get where you get to take off sooner because you're using CPDL DCL, because it makes ATC's job easier. Those equipped are typically first served. And I'll highlight an example of a cargo operator who was about 9th in line to take off at an airport, and weather was moving in. They were using CPDLC DCL to facilitate their clearance. And because of this, ATC was able to facilitate that clearance much more quickly. They ended up getting bumped up in line and taking off just before the weather moved in and closed the airport, leaving a lot of aircraft grounded. So that really helps you realize the benefits of jumping in line using CPDLC, DCL, best equipped, best served. And to answer the last part of your question, you can see here that there are 62 airports equipped and providing CPDL DCL across the United States now.
So I'm going to throw a slight curveball. I know I said we hit some questions at the end, but there was a really good question Bill came up with kind of that pertained to what you were saying there. He asked, what notification does the crew get if the clearance is revised? So you mentioned in that first slide there in White Plains. So how does that happen? So they get a revision. How does the crew know that?
So I can go ahead and answer that one. So when the system receives any CPDLC message from the ground, the system will provide an indication to the flight crew. And this indication is both a light and a chime will go off. So there'll be a chime, a light will come on saying that there's an ATC event. And then when the crew goes and logs into or selects the Unilink from the FMS message page, the open message, it's called open because it hasn't had a response yet. The open message will be the first thing that's displayed on the Unilink screen. So it's pretty simple to get the notification. You get a light, you get a chime, you press the FMS message button, you press Unilink, and your message is displayed.
Okay, I mean, that makes sense, a light and a chime. Hopefully that's all set there with all the other things that go off in a cockpit, but it's kind of what I figured it would be, but that seems to work pretty well. That was a good question. So as we're talking about CPDLC and how it's being used, I mean, we're picking up clearances and how it was really good in White Plains, and we can see by this slide where it's available. We've also got the U.S. Airspace is starting to look at enroute. So on the enroute section, yeah, how does this benefit them?
So I could talk about enroute. There's currently 3 centers shown here in green that are providing the active service. That's Kansas City and Indianapolis and Washington, D.C. Washington, D.C. just went active within the last few months. So if we look at the info slide here, it shows similar types of benefits that were shown for DCL. So it's estimated that since March of 2019, these 3 centers have mitigated over 26,000 readback, hearback errors. Might be interesting to note the way that they estimate these benefits is they look at voice operations and the errors that were occurring there, and they compare the complexity of those voice operations with the complexity of the digital clearances to determine how many errors are reduced or eliminated. The enroute services are also reducing the communication time with over 99,000 minutes of communication time eliminated. And the digital delivery of even complex clearances are delivered quickly, and again, followed by pushing to load the clearance into the FMS with a quick pilot Wilco in response. The en route services are also improving efficiency of the path that is cleared when the controller has to reroute an aircraft around congestion or bad weather. With the ground system that was put into place to support CPDLC en route services, the controller can do what's called a trackball reroute. So in essence, they just pick some points on a map using a trackball to define the most efficient route possible around the weather or congestion, and the clearance is provided to the aircraft with lat long or place bearing distance waypoints. So these clearances are saving distance and time over what a controller might be able to provide, giving the clearance over voice. And this efficiency being received because of data link is reducing fuel burn and emissions. And because the CPDLC system is easy to use, it's expected that crews are going to be more comfortable making a request, such as a direct to. And again, because of the updates made to the ground system to support CPDLC, it's expected that that will improve the controller's ability to actually accommodate these requests. CPDLC also provides a communication method if there's been a loss of voice radio capability, so that adds to the safety as well. And then one final note, you don't need a letter of authorization to use the en route services in like you do in the North Atlantic if you're a Part 91 operator who only intends to use fans in the U.S. domestic airspace. But it is important that even without the no need for the LOA, flight crews are still required to get training. Let's see, so let's go on to the rollout of these services. So the FAA Data Comm program is using a phased approach for bringing all of these control centers online. So, there's the 3 active centers, but the plan is to periodically roll out more services to the additional U.S. centers. And the original plan was to have that completed in mid-2021. The rollout plan may need to be adjusted some because of the coronavirus, but the active service area is going to continue to expand as this rollout progresses. The messaging capability and the services themselves are also being done in phases. So the first phase is known as the initial en route services. And these support transfer of communication and initial check-in when an aircraft is transitioning from one region into another or migrating from one frequency to another. The system can send the flight crew the local altimeter setting for use below flight level 180. Flight crews can request an altitude change, including climb to or descend to altitudes, and receive altitude clearances or altitude with speed clearances from the controller. And controllers can send crossing restrictions to cross at a certain position and maintain a specific altitude. With the initial services, flight crews can request a direct to a fix on their current route. Or they can receive a direct to or reroute or even a full route clearance from the controller. So that's a pretty substantial offering for just the initial services. And then work has already begun on defining the next phase, which is the full en route services. And these are planned to become operational around the 2023 timeframe. These services expand on what's possible with the controller-initiated reroutes by adding support for things like offsets. A time component can be added to your crossing restriction. Flight crews are going to be able to request a direct to a position that's not on their active route. More advisory messages are going to be added regarding things like weather or turbulence or delays. And ATCs will be able to send hold instructions, very similar to the example that's actually shown here on this slide. Flight crews will be able to request speeds, and controllers are going to have a little more flexibility in the type of speed clearances that they can send in return. And the future is going to bring even more capabilities and benefits, and all of this is being made possible by data link technology today.
That's a lot of capability, Lynn. So we have another poll question here. If everybody wants to participate, which data link service offers the most value? ACARS, AOC, and ATS, Oceanic and Remote Continental Fans 1A, European ATE NB1, U.S. Domestic CPDLC DCL, or U.S. Domestic enroute. So which data link service do you think offers you the most value? Right now, we're about 50% domestic CPDLC and Oceanic and Remote Fans 1A. So we're split just about 50-50, Oceanic and domestic CPDLC, maybe a little bit more of it, the domestic CPDLC and DCL. So thank you for your inputs. Appreciate that. So Lynn, we've covered quite a bit of stuff here. Could you quickly summarize what communications can be transmitted using data link?
Okay, yeah, let's do a summary by looking at an average flight. So you're sitting at the gate, you get your filed flight plan from AOC, which can be loaded into your FMS. Then you can digitally get your departure, your DATIS for your departure airport. You get your clearance from ATC and load that revised route into your FMS with a touch of a button. You process the squawk code, you set your frequencies. Then you leave the gate and the aircraft takes off, and the time and fuel on board at each of those events is automatically sent to your ground host so they can track your aircraft progress. Upon entering an active CPDLC en route region, you receive a welcome message from the active center notifying you that CPDLC services are available for use. You request some updated AOC wind data for your route. See that maybe there's a more fuel efficient altitude, or maybe there's a different altitude you'd like to avoid turbulence. So you send an altitude change request to ATC and receive that clearance in return. Then because the system's so easy to use, you go ahead and try a direct to. You get that clearance, and that cuts time and distance from your trip. So you send an ETA update to inform your ground personnel of your updated arrival time. Finally, the time and fuel when you land at your arrival gate are automatically sent to your ground host. And this is just one scenario. The information that's exchanged for any given flight is very different based on what's needed to fly that particular route that day in a safe and efficient manner. And it's important to note you can do all of this today with the Unilink UL 801 CMU. None of this is future capability. It's all available today. So over the years, ACARS operators have continued to replace the voice and paper communications with data link. So anybody that's installing Unilink today can benefit from decades of this ACARS expansion. And the growth in this area continues. So the flexibility that Amanda spoke about earlier about the databases and being able to load in new capabilities, that supports an operator's ability to update their ACARS AOC services without any Unilink software modifications at all. And something I didn't note that also might be important, all of the expansion in the en route services, FANS en route CPDLC services, all of the message capability needed to support those services is also already provided by the Unilink today.
And so there's a ton of benefits, obviously, for the flight crews and the passengers using this technology. And, at Duncan Aviation, we do everything nose to tail on the airplane. So we have a lot of director of maintenance that sit there like, hey, this is great technology, but how many boxes does it take, and how many wires, and how hard is it to maintain this thing? Because we've seen avionics get more and more complex. Director of maintenance, they've got to do everything from maintaining the airplane, the engines, the airplane. Now they have to take care of internet. So I think a lot of them are curious on how complex the system is.
So to start with, there are no maintenance requirements for the Unilink. It's that easy. The Unilink supports the field loading of databases and software. So when it's interfaced to a data transfer unit, databases and software can be done in the field. And these are infrequent, but it sure beats having to coordinate during downtime to pull the Unilink and send it into the repair station for those updates. If a customer has a legacy Unilink and they want to replace it with a current Unilink that supports the fans and the ATMB1 and the technology we've been talking about that's rolling out in the US domestic airspace, the upgrade is simple. Plus, the UL801 model has an embedded VHF data link radio, so this eliminates the need to install an external VHF data link radio. Troubleshooting is also very easy. There's a lot of built-in features in the Unilink, such as link logging. It captures all that traffic going back and forth and can help with some troubleshooting. Status pages, and you also have the ability to exercise discretes at the push of a button. And to top it all off, UA has a track record of offering high-quality training, technical, and repair services. We are available for AOG services 24/7, 365.
Amanda, thank you. Thank you. So when we talk about Unilink, we've obviously got to talk about the path to get it installed on the airplane. Here are the available Unilink STCs for Bombardier, Gulfstream, Boeing, Dassault, Textron, Airbus aircraft. I'm happy to say that some of these STCs are owned by Duncan Aviation. We at Duncan have 24 full-service avionics satellite locations. We've got 3 huge MRO facilities, a new location in Provo, Lincoln, and Battle Creek, Michigan. Plus, we have workway locations and rapid response engine teams. We've been partners with Universal Avionics for a long time. We're constantly working together with those guys to offer you the most cost-effective solutions we can, whether it's Unilink or FMS upgrades or displays. And as Michael said, we're a full-service provider. Everything you can imagine with the airplane, Duncan Aviation can do it. If you have any questions or you'd like to reach out for more information, here's all our contact information. I think to close things out, Michael, it would be a good time to review any questions that are out there and provide some answers.
Yeah, I'll get to the questions, and I think you were going to discuss some opportunities for the operators. So you want to say that right after the questions, I'm guessing?
Sure.
Okay. So normally we have the cute little, hey, here's the question slide, but I'm going to leave it actually back here so you can see our mugs and get all our email addresses down. We do have some good questions, so hang on here. One of them is about training. Does Universal Avionics offer any data link communication training for operators?
We do. So currently we offer Unilink operational familiarization in the classroom, and because of the impact of COVID-19, we are doing virtual instructor-led training as well. We're developing online courseware for self-led training, and this will be available in our online learning center, UA Academy, sometime around fall, the end of the year at the latest. And both of these courses will be submitted, the classroom instructor-led course, the virtual instructor-led course, and the online self-led course are going to be submitted to the FAA for approval. And what this means is that for those operators that need to get an LOA to operate in PBCS airspace, they can take that training and it can be used on their LOA application. One thing I do want to emphasize talking about operational training is that even if you are going to use data communications in non-PBCS airspace, meaning you don't need an LOA, operators are still expected to use the equipment properly. If they burden ATC with improper use, or they contribute to making the airspace unsafe due to improper use, the privilege of using CPDLC can be revoked. And I've seen this happen to some operators. I encourage everyone who uses the Unilink for CPDLC, whether that's in PBCS airspace or not, to come to us for some familiarization training. On top of the operational training, we offer technical training as well. So we can educate the DOM, and we can also do a deeper dive for our dealers on integrating and installing, certifying the Unilink. This can be used on the inspection authorization renewal. So everybody just keep your eyes open for the launch of our self-led training, our online learning center, UA Academy, and contact me if you have any questions or you're interested in some operational instructor-led training.
Perfect. We jumped a few slides back because we had some people that are interested in the STC list. And again, if there is a slide you guys want to see, let us know. We can move it around a little bit. We've got a few more questions. Bill, again, how does ATC know the level of service the aircraft has?
So, as I had commented earlier, the service, the equipment capabilities, and the level of service that your equipment installation supports are part of your flight plan filing codes. Two of the fields are used. I believe they're field 10 and field 18, going off of memory here. Um, and you identify that you have a data link equipment, that it's VDL mode 2 radio capable, whether there's a SATCOM system installed with it, whether you support the appropriate level of performance-based communication surveillance um, with the equipment that's on board, whether you can support DCL clearances, and whether you have push-to-load capability, which is required to support the enroute services. You don't need push-to-load for DCL, but push-to-load is required for the U.S. domestic enroute services.
Okay.
And there's actually Harris.com has a website, and there's a list of documentation there, and one of the documents on that site is a flight plan filing guide. So it's very useful information that people can go out and find, and it lists all the details of what you need to file to support at least the DCL and enroute services.
Okay, perfect. And actually, I've been to the Harris website. I will admit, I mean, if you want to learn more about CPDLC and fans, your guys' website and Harris's website, I'm quite impressed. I mean, there is a ton of information that you guys provide for free. So that helps. Jack's got a good one. Is third-party service providers only required for AOC services, since ATS services are direct to ATC?
So I can cover that one as well. So the messaging and the network usage time for doing U.S. domestic CPDLC and domestic ATNB1, that messaging cost is covered by the region providing the service. In order to use fans, though, you do have to have access to the ACARS network. So you will need to be in touch with a third-party reseller of the ACARS service, the ground host. But most of those providers, is at least as much as I'm aware, have a tiered service offering. So there's different prices that are available. I believe they're monthly subscriptions, or maybe they have a yearly service subscription as well. But there's different prices depending on what services you want access to. So I would imagine that a ATC only service would not be very expensive, because you're not paying very much of the network usage charge there.
Okay, sounds good. Got another good one. What are the ramifications for the CVR? Isn't it required to record the CPDLC communications?
So in most cases, you do have to be equipped with a data link capable CVR if you're going to be using fans, CPDLC messaging, and that's because what would have been caught on the area mic or the pilot or co-pilot audio is now being replaced by data communication. So we still need to have a way of logging that and capturing that exchange of communication. I do want to mention, though, that Universal is working closely with Duncan to offer some really great stimulus pricing. So, you can get that CVR in there and really take advantage of the great pricing packages we have right now.
Perfect. So far, I think we've got one more. What subscriptions are needed to use data link communication, and how much do they cost?
So we don't really know the prices for the people that are providing the business aviation community with the data link services, the AOC service offering. But there are at least 3 providers that I'm aware of: Satcom Direct, ARINC Direct, and Global Data Center. That list is also available on the Universal Avionics website, uasc.com, with contact information. So you can go there, figure out how to contact those individuals, and check out pricing individually.
Sounds good. I think we're wrapping up most of the questions. And again, if you're like me, you'll think of a question at 3 o'clock in the morning the next day. This presentation, I believe, will get sent to you. And so you can email any of us those questions and we will take care of you. There are still a few questions out there. We'll reach out to you directly on email. And again, thanks for tuning into this webinar. It's been a pleasure. If there are other subjects about this, or if you want to learn more about different parts of CPDLC, feel free to let us know what those might be. Obviously, we saw a lot of people are looking to increase the efficiency of their flight using this technology. So we'd love to do more of these if you'd like. And again, thanks so much for tuning in. Feel free to reach out to us at any time and have a wonderful day. Talk to you later.